Uh, so this solution is for the last week assignment, problem 2, which I missed in my previous assignment. Thank you so much for alerting me. I'm not sure how I missed it, but anyway, I think I solved it in IDE, which we don't want to do it. And moreover, I did it in big of n time. So okay, so coming to the problem, I need to find the magical index in an array. So last week what I did was I just used, okay, so before that let's take an array as example. Let's say -10, -1, 0, 3, 10, 11, 30. Okay, I think it's enough because we already have a solution here. So last week what I did was I used a for loop. So I just did a linear search. Uh, so I had a function define binary, and it is taking array as an example. So now it's gonna I used for I in range 0 to length of a minus 1, and then I'm just using a condition. If a of I equal to I am returning I. If not, just return -1. But this solution is taking big of n time, but last week I missed the array is sorted, which I missed in last week. So since array is already sorted, we can do a binary search. So in the binary search, what I'm planning to do is, like, basically I will find out the mid value to see if it is already a number which is matching to this condition right here, these two lines. So if it is satisfying this condition, I will just return this number. If not, if this number is greater than the pivot, the fixed number, then we know the solution into the right side. If not, it is just into the left side. So to solve this problem, I'll have a function called, I will call it as a search. It's gonna take array as an example. I think I'll just pass another two variables which I'm gonna use, which is start. So initially start is gonna be 0, and end, so end is length of a. I'll be using a recursive approach for this problem. So as a base class, as a base condition, I will have if end is greater than or equal to start, what I'm gonna do is I will just mid-level midpoint, which is gonna be start plus n by 2. And now I'll be using the same condition here. So if mid equal to array of mid, then we return the mid. So here we are returning I, but instead here we are returning mid. But if this is not the case, we have to move to another condition where this mid is greater than array of mid. So if this is the case, we have to change the boundaries. The start is going to be the midpoint and end is going to be constant. Since we already are having these all here, I'll be using a recursive approach like search. I will just pass the array, and here the start will be like mid plus 1 and end is gonna be constant. We don't change anything end here. But if this is not the case, if mid is a less than array of mid, I think we don't have to mention anything here, because this is the last condition which I wanted to check. We will be changing the boundaries at end. So return search a low. Here this is the one which is going to change, mid minus 1. So if we don't find anything in these conditions, we will be returning -1. So if we see here the same problem, so this is an array, right? So this is a sorted array. So we will be checking this condition right now. So initially it is -10. So this is definitely, it's not, it will get the mid condition, it will get the midpoint here. So 1 2 3 4 5 6 7. So this is the midpoint, as we know. I think it just returns this point. Okay, let's say we have another variable here, 2 0 and 1. So now it is like 1 2 3 4 5 6 7 8. 1 2 3. So this is our midpoint, so which is 4. So now this point is greater than the mid element. So now we know the solution lies here. So it is in between these two lines. Now we again call the same function with a reduced start condition. So we'll be starting from here, and then we do the same thing. Now this is the midpoint, it will search for it. This number is greater than I, so the answer should lies here. The only number we have here is like number 3, so it's gonna return 3. So this is like big of n log n, sorry, big of log n solution, because we are not entirely, every time we are reducing array into half, and we're not using any extra space, so it's big of 1. This is the solution.